Okay. Good day, Great Cove. This is Mrs. Tole from Emerson Private Tutors. So today we are going to do a vertical projectile motion for Great Cove. So what we're going to cover today, we're going to define the projectile. What is it that we call a projectile, and also what is it? The use of equations of motion, okay, to determine the position, velocity, and displacement. What call of a projectile at a given time. Okay. Now, the first thing that we need to understand, again, a recap, scalar quantities, those are quantities or variables with magnitude only, okay, like time is in seconds, distance is in meters, speed is not in meters per second, okay? So that's what you just have to remember that, oh, am I dealing with a scalar? Am I being asked of vectors or what, okay? So that if it happens that your distance, you find your distance as negative, you must know that, all right, I mustn't give my final answer as a negative. I must make sure that it's not negative, it's a positive, okay? Because it doesn't include what called direction, okay? Now, vector quantities, if you get a velocity as a negative, it means that, yes, it's going on the opposite direction, okay? Okay, so it means that it does make sense, okay? So, but speed here, to give a speed with a negative, it means that there is something wrong. But unless if it's velocity, which it does a magnitude in direction, okay? So, in displacement as well, displacement, you must always remember that it does involve what called direction. So just make sure that your answers actually give your answers correctly. Now, what is a projectile? So a projectile is an object that is actually explained, that is thrown into the into the air, okay, and it does experience only what you call a force of gravity. So the only force that is an object experiences is only what called gravitational force. Okay. So and then another thing, free fall. Free fall is an unhindered movement of an object, okay, in the gravitational field of the Earth. So projectile does experience free fall, okay, because there is no other there is no other effect there. So when we talk of an object, free fall of an object, the example, if you drop a pen in a car, we expect that they will reach what call the ground at the same time, okay, if there is no air resistance, okay. Now let's see here, what is acceleration due to gravity. So this acceleration of of a falling object as a result of attraction of gravitational force of the earth, okay, in the absence of forces such as air resistance. Okay, so all objects experience same same force of gravity, same force of gravity. Then what is it? A projectile fall freely at a constant gravitational force of 9.8 meters per second. Therefore, only magnitude and direction of velocity changes during free fall. So remember, if we are throwing an object up, it is still experiencing 9.8 meters per second. If we are throwing it down, it's still experiencing the same same acceleration. Okay, so that's just remember that the same gravitational force is all objects, they do experience same gravitational force, irrespective of the direction, okay, or magnitude of the velocity. Okay. Now, different types of projectiles here that what we have here, you can either drop an object. So if in this case here, the V initial will be equal to 0 because they're just dropping it, it doesn't have any initial. Then in the other case, where you have where you have to throw up something up, it means that it goes up and comes down. It means that it does have initial velocity, but at its maximum height here, the final velocity there will be equal to 0. The velocity there will be equal to 0 there. Okay, and in this case here, we are throwing an object at an angle which is not 90. Okay, then what you need to understand here, this is a very important diagram that you need to understand there, is that because what you see there is one, time symmetry. You must understand the concept of time symmetry, that if you throw something up, okay, the time it takes to reach its maximum height and to come back to the ground is the same, okay, it's the same. So in this case here, the time it reaches its maximum height is half the time it reaches the time it will reach the ground, okay? So it means that the time it takes from this point here to this point, final point here, is actually twice the time it reaches its maximum height. Now, So in this case here is, in this case, 2 seconds to go up and 2 seconds to go down there. Then another thing there is that is the concept of what called velocity. So the velocity an object leaves, maybe what called, let's say I throw something up from my hand here, okay? The time by the time it reaches, it come back here, it will come back with the same velocity. So I throw something with the initial velocity of 10 meters per second, it will come back with what called 10 meters per second, okay? So just know that same height, if is the same, you see here, like here, 5 meters per second, 5 meters per second, is the same height, okay? So that's what you must remember, that the symmetrical concept of what you call, what is it? Symmetrical concept of your time, symmetrical concept of what you call of also your velocity, okay? Then equations of motion, we're going to use equations of motion to calculate the position, velocity, and displacement of an object at a given time. Now, you must always remember that when you're dealing, like what we spoke about during what called in momentum, that you must determine the positive side. So if you can choose that going up negative or going down is positive, whatever you think, but you must be able to tell which direction is you are going to consider as positive, okay? Then those are equations, a list of equations of motion that we have there, and you must know that, right? V initial, this is V is V initial, V initial, the speed or velocity is start with, okay? An object start with, and V final, the object, that will be the final velocity, and the acceleration A is the same as what you call your G, and this gravitational acceleration, which is 9,8. And this thing is constant, is constant, okay? 9,8 is constant. Whether throwing it up, whether throwing it down, or dropping it, is still experiencing 9,8 meters per square second. Now, the change, that's lambda t, the change in time, is your time in seconds. And what we have here is that, what is it? Change in the change in y there is displacement. So you can also see change in x, lambda x. It actually shows that, all right, that's your change in in x, okay? So remember, we're going to only deal with the vertical projectile motion. So we're going to deal with what we call up and down only. Now, what you need to do in order to tackle equations, okay? You must read the problem carefully, okay, and choose direction of motion. If you're working with two sides here, both upward and downward, okay, you must actually be able to tell which one is positive, which one is considered as negative. Then identify and write down what's given to you and what is asked of you. So here's the thing now. When you're presented the question, you must write down what is available to you first, then what is being asked of you. So in that case, you'll be able to choose your equation wisely. Okay, you can be able to choose the equation wisely. Now, after the calculations, you must give correct units and direction. Remember vector quantities. If you're going to calculate maybe velocity, you must always remember that I need to actually determine in which direction. Okay, in which direction? Yes, it's 20 meters per second, but in which direction now? Now, another thing, your V initial is equal to 0 if object starts from rest. So whenever they state that it starts from rest, you know that, oh, V initial is 0. Or if something is dropped, okay, it means that your V initial will also be 0. Then again, its maximum height, okay, is actually the turning point. You must always remember that the V initial is 0. As you can see here, maximum height, its maximum height here, the, what is it? The V is 0 meters per second, okay? So let's attempt some questions here. Okay, let's attempt some questions here. Okay, so now let's see what we have here. Now, the question is, a ball is thrown vertically upwards with the initial velocity of 10 meters per second. Okay, then determine the maximum height above the what called the thrower's hand are reached by the ball. Determine the time it takes the ball to reach its maximum height. So a photograph, okay, is taken when the ball is 1,5 meters above the point of release, means above the hands of whoever is throwing here. Now determine the time. Determine the times, okay, the times when the ball will be at the position which is 1,5 meters what called shown in the graph. So when the ball is what called 1.5 meters above the hands of what called the thrower. Now, the first question. So let's get to do the first question here. The first question we are asked to determine what called the maximum height, which is change in y. Now, what is given to us here? V initial is equal to what? V initial is 10 meters per second. What is V final? V final, remember, it reaches maximum height. At maximum height, we know that, oh, maximum height is 0 meters per second because it's not, the velocity is 0 there. Then what else is given there? Okay, you know that acceleration is always, what is it? It's always there and it doesn't change, meters per square second. Okay, then what else do we need to check here? That's all what we have here. So, but what are we looking for? We are looking for change in y, which is in question. Okay, now let's get to see which one should we choose here in this equation that we have here. Okay, so if you can see there, what are the equations that we can do? If we check here, we can't take this one because of change in time. We don't have change in time at the moment. Now, in this case here, we have what called, we have all what we need, and what we are looking for is change in y. But in these other two equations, again, they're the same as the first one because they do have time. So we don't have time, so we actually exclude these two, these three. Okay, so we're left with only the middle equation that that's what we're gonna use. Okay, so what does it say? It's saying V final squared is equal to V initial squared plus 2a change in y. Now, what is your V final? V final is going to be 0 squared is equals to, what is it here? It's going to be 10, also 10 squared plus 2, 9,8 change in y. Okay, that's what we have there. Now, what are we going to do there? We're going to, if we were to say 10 squared is 100. Okay, 10 squared is 100. So we're going to say here it's going to be 2 times 9,8. 19,6. So you can say 19,6 change in y is equal to, if we take this one, it's going to be negative 100. Okay, it's negative 100 there. Then what I'm going to do, the change in y is going to be equal to negative 100 divided by 19,6. Then what I'm going to do there, negative 100 divided by 19,6. What do we get there? We get negative 5,102 meters. Okay, but understand something here. This is height, and we just want distance. This is distance in this case. So we know that it's supposed to be positive. We can't have negative here. Okay, because it's just height. Okay, so we're going to say therefore height maximum is going to be equal to 5,1 meters. Okay, that's our answer there. Simple as that. We are excluding the negative because we know that the distance, the height is actually a scalar. We don't need to worry about the direction. That's the negative there. We don't need to worry about the negative. Okay, so we need to exclude that. Now, that's what we have. So second question here. What is the second question saying? Determine the time it takes the ball to reach its maximum height. Okay, now we already have height here, which is equal to change in y, which is 5,1 meters. Okay, what is given to us there? Then our V initial is equal to 10 meters per second. Our V final is equal to what we call 0 meters per second. Okay, then what else do we have here? Acceleration is 9,8 meters per square second. Okay, now what else do we need here? We are looking for what? We are looking for change in time. That's the one in question. That's what we're looking for. That's what we're looking for here. So what are we going to do? We take our sheet again. We say, all right, now this is the list of what is it of your equations here, and we're going to choose what is here. Now, which one should we take? We want change in time, and here is equation here. We have everything that we want here. we go to V final, we have it, V initial, we have it, we have acceleration, we are looking for change in time. But why not this one here? This one here is what? This one here doesn't have time. You're looking for time, so this one is actually out. Then this one's have got time, but you look now what we have here. These ones have time, and here we're going to have a quadratic equation for what? We don't need to worry about that. We don't need that. We don't need this one because it's going to take long here. It's going to take long. So let's work with the first one. Okay. So the first one here is going to be V final is equal to V initial. Okay. V initial plus what is it? A change in time. Now, what is our V final? Is 0, which is what is our V initial is 10. What is our acceleration? 9,8 change in time. That's what we have there. Oh, is it correct? Yes, that's what we have there. Then what are we going to do here? Change in time. We want change in time. So it's going to be 9,8 change in time. Okay, is equals to negative. Remember what I just did here? I just moved this one. It's going to be negative. Okay, so I'm just going to start with whatever we're looking for here. That's why I'm writing it like this. Okay, so it's going to be negative 10. Now our change in time, we divide both sides by 9,8. Okay, it's going to be negative 10 over 9,8, which is going to give us what? Now we're going to say here negative 10 divided by 9,8. Okay, what do we get there? We get negative 1,02. Okay, now again here, what we have here, change in time, we can't have negative as in terms of time, so we don't need to worry about the negative here. It's still positive. So our change in time here is actually going to be what is it? 1, sorry, not negative anymore, 1,02 seconds. That's it. Then you're done. That's your final answer then. Okay. Now, let's see the third question here. The third question is saying what? Now, determine the times when the ball will be at the position which is that 1,5 meters shown in the graph. Okay, let me just show you what is that we're talking about here, the graph that is being talked about here. Okay, so that's what we have there. That's a photograph here that we're looking at here. So this ball is 1,5 meters here. Okay, 1,5 meters. It hasn't reached its maximum height yet. It hasn't reached its maximum height yet. So it's still going, but by this time here, it was actually 1,5 meters. Okay, so now I want to find the times, okay, where this ball was at this point here. Okay, so at this point going up and at this point coming down. So it means that we need two values of your time. So your time should be 2 there. You must get two values. The time for the first one when it was going up, and the other one when it was coming down. Okay, that's what we have there. Okay, so let's get to see how we can actually calculate. Okay, so what is available to us there is our what? It's our okay, solution. We have V. Okay, now, all right. Now what we have, I think we forgot something here to choose the side, because this is gonna go up and down. So let's choose downward as positive. Okay, so if we choose downward as positive, it means that our initial velocity here will be negative, and it will be negative here, but it's gonna still give us the same answer here, because if you square a negative, it gives you a positive value. Okay, now and that is why also here you find that your value here will be negative here. Okay, then again here, let's see here that all right, our initial velocity should be negative. And if it is negative here, it means that here it's going to be negative like that. Then it means that it's going to give us what? A positive value, but still the same answer. Okay, so here was supposed to be a positive value here. we're supposed to get a positive value, which is fine. So now let's see our problem here. Our current problem here is saying determine the times when the ball will be at the same position. So we're going to say, all right, our V initial here, our V initial is -10. Second, okay. Then our displacement, which is our displacement here, which is change in y, is also -1.5 meters because it's above this. We are going this way direction here. Then what else do we have then? What else do we have? We are looking for what? Acceleration is 9.8 meters per square second, and we're looking for change in time. Okay, so we're looking for time here, but remember we're going to choose which equation here that we're going to choose here. We're going to choose, we can take this one, okay, because here remember the question is saying times, so it means that this ball is going to be on the same position, okay, twice, when it's going up and when it's coming down. So that's what, like I said before. So we're going to choose a quadratic here because we need two values of t. So we're going to say, all right, the quadratic equation that we're going to choose is the quadratic equation here that gives us what we call a quadratic equation. Now we're going to say change in y is equal to v initial change in time, which is equal to half acceleration change in time squared. Okay, then now what do we have now? So we're going to say now, let's say what is going to be your what is it? Let's take it this way to say half a change in time squared plus v initial change in time is equal to change in y. Okay, I like it to write this way so that it's going to be easy to actually to simplify. Okay, now here it's going to be half, let's put the detail, half of 9.8, okay, t squared, it's going to be t squared plus what is our v initial is -10, okay, t, okay, minus, because we're going to take this one into inside there, might be minus 1/5, 1.5, sorry, is equal to 0, like that. Now what will we get here? We're going to get 4.9 t squared plus, sorry, minus here, minus 10t plus minus going to give us plus 1.5, 1.5 is equal to 0. Now I'm going to say, all right, let's just say let x equal to t. So we're going to use the quadratic equation here, which is minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, now what is our a? Our a in this case here, so it's supposed to be 4.9x squared minus 10x plus 1.5, okay, is equal to 0. Then our a here is going to be 4.9. Our b is equals to -10. Our c is equals to 1.5. That's what we have there. Then what we're going to do here, let's substitute there. It's going to be minus 10 plus or minus square root of what is b squared minus 10 squared minus 4a. What is a? What is a? A is 4.9. What is c? It's 1.5 all over 2. What is our a? 4.9. Okay, so let's input it in our what call this equation in our calculator there. We're gonna say, all right, it's minus 10, okay, plus, okay, square root of, yeah, also master how I'm punching here in the calculator, minus 10 squared minus 4, what is our a? 4.9. What is our c? 1.5. Okay, then you go down there, it's gonna be what? 2 times 4.9, sorry, 4,9. Right. Now, what do we get then? We get, so if it is plus, our what is it? Our t there is gonna be what? Our t there gonna be 1,8777 like that, or we put a negative. Remember, it's plus or minus here, so we can also put also minus there. We delete there, put minus. What do we get? Or 0,163 goes on like that. Now, so here, what are we going to do here? We're going to say, all right, our t there, our t is equal to 0,16, or t is equal to 1,88 if we round that. Okay, second. So here, what it means here, it means that the ball will pass going up. When it's going up here, it's going up here at 1,5 meters. Then it will reach the same point here when it's coming down. So here it will be coming, going down there. It's also at what we call 1,5. So because you can see there is 0,1 or 0,16. After that, it goes up, it reaches maximum height, then it comes down. Then after 1.8 seconds, after being thrown, it will actually reach the same point here, 1,5. That's what we have here. And remember what we said here is actually the, what is it? The time symmetry here, the time symmetry that you could take also in that case. But in this case here, 1,5, you must always remember at the same point here, it will actually reach the same time. Okay, so even if you are to solve these equations separately, to maybe find the initial time here and find another one using different using on the other side, you can still actually find the same values. Okay. Now let's see the next question. Okay, let's see the next question. So the next question here is saying. The next question here is saying, a cricketer hits a cricket ball so that it goes vertically upwards. If the ball takes 10 seconds to return to the initial height, determine its maximum height above the initial position. Now, here I've tried to show you here that, all right, we are saying from initial here is time is 0, okay? Then it goes up, it reaches maximum. At maximum here, that's time maximum. Then the velocity is equal to 0 there. Then it comes back, okay, to the same position, okay? So it's actually 2 times, because remember of time symmetry that we said. So the time it takes to reach there and the time it takes to actually from this point to this point is the same. So we just have to divide that time, the 10 seconds by 2. So in other words here, if we want to determine its maximum height, okay, it's in other words here, we're going to say going up. So let's take upward as what? Upward is what is it? The initial weight. Determine the maximum height above the initial position. Okay, so we're gonna take upward here. You can take upward. Let's take upward as positive and C. Now, if we take upward as positive, it means that our V initial is gonna be what? V initial, we don't know. We don't know that one. Then our V final, we have it. V final is equals to 0. Okay. Then what else is given to us? We are looking for the time. We know that time is going to be equals to 10 divided by 2, which is equals to 5 seconds, okay, to reach maximum height. Then what is it? What else is given to us? Our time is actually the one that we're looking for. Time, we have it, sorry. Our Y, that's what you're looking for here. Then we take our sheet here and see which equation should we use, because we do have, what is it? We are given final velocity, okay? We're given final velocity, and we are also given what? Initial velocity, we're not given. Initial velocity, we're not given. We're only given final velocity. So I think here we need to be clever here and see, all right. From this point here to this maximum height, we want the distance here. We want the change in y, okay? But now the thing is now what we have here is that our v final, if we are to start from this point going up there, okay? But the thing is now, we need to be clever here. Let's use from the top and refer this one as our v initial going down there. Okay, that would be wiser for us. Okay, so what are we going to do here? We are going to say, all right, we consider this as our v initial, the maximum at maximum height. Okay, and what we're going to do there, we're going to say, all right, our v initial in this case, it will be 0. Okay, so that we can find the equation that we want. Because here, if we are to check the equation with the v final here, with the v final only, you can't have it. But we can only have this one, the v initial. So we need to be very much smart here and say, all right, what are we going to do there? Sorry, can you see it now clearly? So we don't have any equation there that only have v final only. So we need to choose this one with only v initial. Okay, then we can actually find our answer. So we are going to take this initial this velocity at maximum point as our initial velocity. So it's going to be 0. Then our time, remember it's still the same, it's going to be 5 seconds. Then our change in y is what we're looking for now. Now, let's see what we're going to do there. So let's see which equation should we choose here. In this case here, we're actually going to choose the third one, the third equation, okay? Because these two requires v final, and we don't have, this three requires v final, and we don't have the v final. So we're going to say, all right, our change in y is equals to v initial change in time plus half a change in time squared. Okay, now what is our change in y? We are looking for that, isn't it? We are looking for that. So we're going to say our change in y is equal to, which is going to be 0 t, which is here 5 plus half 9,8 5 squared. Okay, then this actually probably gonna give us 0 here. Okay, it's gonna give us 0. So we're going to say, all right, let's see what we have here. 1/2, sorry, times what? Times 9,8 times 5 squared. What do we get there? We get 122,5. 122,5 what? 122,5 meters. Okay, so it means that change in y, our height there, because we asked to find the maximum height. So height max is going to be equal to 122,5 meters. That's how easy it is. So remember what we just did now here, where you will be struggling to say, all right, I know my at maximum is v fine, it's my article is 0. Okay, but now use that as a reference point to say, all right, that will be my v initial, and work it out from there. So because it will be given to you, and the only equation with the equations that we have, we can only have one. This one with the v initial. You can't have what called v final on its own. Okay, so that's what you need to be smart about. Okay, that's what you need to master here. Okay, so this marks the end of our lesson. Okay, so today you've mastered how to you've understood projectile, what I mean by projectile, and the use of equation of motions, what you're supposed to do, in order to get your answers, and what else do you understand there? Weight, maximum height, the v is actually 0 meters per second. Okay, and when something is dropped, its initial velocity is actually 0. So guys, subscribe to our YouTube channel, and also follow us on YouTube, on our Facebook, Instagram, and Twitter for updates. Okay, so until next time, and also share, please, guys. Thank you so much. Until next time.